Hello, and welcome to today's lesson where we're going to look at special points of concurrency, our intersecting points when dealing with triangles. Okay, so now when we talk about the term concurrent, that means that three or more lines that have a point in common. Okay, so if we look over here on the left, two lines have this point in common, two lines have this point in common. Okay, so a point of concurrency needs more than 2 points. Okay, it needs 3 or more points intersecting at a single place. So now we're going to look at some of our conjectures because these are going to be important conjectures that we can use in different situations. Okay, the three angle bisectors of a triangle are concurrent, and the point of intersection is called the incenter. Okay, and what you want to remember about the incenter is a point that is the center of an inside circle. Okay, so we have an inside circle in the incenter. Okay, so that point is equal distance from all three sides. Okay, so what we could do is we could construct it by finding the angle bisector of all of the three angles. Okay, using those angle bisectors to draw the segments and find that point that they have in common. Okay, so what we want to remember about the incenter. The incenter is created with angle bisectors, and it creates an inside circle, so the point is equal distant from all three sides. Okay, now, if we look at perpendicular bisectors, so these lines are cutting each side in half, and it's cutting it in half at a 90-degree angle, or a perpendicular line. Okay, the three perpendicular bisectors of a triangle are concurrent, and the point of intersection is called the circumcenter. Okay, now the circumcenter is the center of a circle, but it's a circle that's equidistant from all three endpoints of the circle. Okay, so the circumcenter is the center of an outside circle, not the center of an inside circle. Okay, and we can use that radius as we go. Okay, notice that the circumcenter might be outside of the triangle. Okay, this happens when the triangle is obtuse. Okay, so if you have an obtuse triangle, the circumcenter will be outside of the triangle itself. Okay, so now let's look at these two situations here. We've got the three cities, Safariville, Maxwell Heights, and Tutstown. Okay, so it doesn't matter where the cities are located. Okay, they want to put in an ice arena that is equal distance from all three high schools. So it needs to be equal distant from all 3 points. Okay, so now, if we want the situation that's equal distance from all 3 points, is that an incenter or a circumcenter? Okay, let's go back and look at the two. Okay, circumcenter is the one that's equal distance from all 3 points. The incenter is the one that's equal distance from all 3 sides. Okay, so in this situation, we would need the circumcenter. Okay, and then we jump down to the next one. Okay, the city of Bolinia. Okay, we've got 3 roads that make a triangle: Eagle Avenue, Skipper Road, and Gusty Parkway. Okay, the mayor of the city wants to put a drinking fountain that is equal distance from all 3 roads. Okay, not equal distance from all 3 points. Okay, so for equal distance from all 3 roads, we can see that the circle is inside, and we would use the incenter for that situation. Okay, now, third type we're going to look at today, okay, the intersection of the 3 altitudes. Okay, so this is the one point that's perpendicular to all 3 sides. Okay, so the 3 altitudes of a triangle are, hopefully you can guess this one now, concurrent. And the point of intersection is called the orthocenter. Okay, so the orthocenter is the point that is perpendicular to all 3 sides. Okay, so it's the intersection of all 3 altitude values. Okay, and we've got that point, you know, creates a 90-degree angle with this side, creates a 90-degree angle with this side, creates a 90-degree angle with that side. You have to extend your sides sometimes when the triangle is obtuse. Okay, now, so let's take a second and kind of fill out our table here. Okay, the first special segment that we looked at within the triangle was the angle bisectors. Okay, the angle bisectors created the incenter, and the incenter is equal distant from all 3 sides. When we used perpendicular bisectors, we created what we call the circumcenter, and that creates a point that is equidistant to the vertices or corner points. Okay, so the angle bisectors create the intercenter, which is equidistant from the side lengths. The perpendicular bisectors create the circumcenter, and that is a point that is equal distance from the vertices or the corner points. And then if we use the altitudes, that creates the orthocenter, and that is the point that is perpendicular to all 3 sides. And then there's one more that we'll tack on in our next lesson. Okay, so that concludes this first part of today's lesson, where we're looking at the special types of points of concurrency that we can create within a triangle. Thank you, and have a good day.